So here is the Chapter 3, Part 1 review for your midterm. Number 10, what is the difference between uniform and non-uniform motion? Classify each of these as uniform or non-uniform motion. A rubber stopper is dropped from your raised hand to the floor. That would be non-uniform. A car is traveling at steady state of 85 kilometers per hour due west. That is uniform. A rocket begins rising from the launch pad, non-uniform, and a motorcycle rider applies the brakes to come to a stop, non-uniform. 9, what is the difference between a vector and a scalar? Be able to identify examples. Vector is described by magnitude and direction. Scalar is described by magnitude only. Examples, identify the following. 30 newtons to the right is a vector. 40 meters per second is a scalar. Speed is a scalar. 10 seconds is a scalar. Distance is a scalar. 20 meters per second squared to the north is a vector. Velocity is a vector. 2 cups is a scalar. Displacement is a vector. Acceleration is a vector. 20 meters is a scalar. 12 books is a scalar. Calculate distance and displacement for various scenarios. That's number 8. If you walk from your house to your friend's house 5 kilometers away to the north, what is your distance? It's 5 kilometers. What is your displacement? 5 kilometers north. Second example, if you walk from your house to your friend's house 5 kilometers away and then return home, what is your distance? 10 kilometers. What is your displacement? 0, because you start and end in the same place. Third example, if you travel to a store that is 15 kilometers north of your house and then return towards home, but only go 10 kilometers before stopping for ice cream, what is your distance? It is 25 kilometers. You get that from 15 plus 10. What is your displacement? It is 5 kilometers north because you went north 15, turned around and came back south 10, and so you're still 5 kilometers north away from your home. Number 7, know the formula for speed and be able to rearrange it. What is the formula for speed? Speed equals distance over time. Can you rearrange it for both distance and for time? Number 6, using the formula for speed to calculate any of the terms. So what is the speed of an object that travels 20 kilometers in 10 minutes? And speed equals distance divided by time. 20 kilometers divided by 10 minutes is 2 kilometers per minute. Be sure you have the correct units. Second example, what is the distance traveled by a vehicle traveling at 20 miles per hour for 4.5 hours? Distance equals speed times time. So 70 miles per hour times 4.5 hours, and you get 315 miles. Third example, how long will it take you to reach a destination that is 400 miles away if your average speed is 50 miles per hour? Time equals distance divided by speed. So that's 400 miles divided by 50 miles per hour, and you get 8 hours. Number 5, know how to calculate speed and velocity. So if you walk from your house to your friend's house 5 kilometers away north in 1 hour, what is your speed? 5 kilometers divided by 1 hour equals 5 kilometers per hour. What is your velocity? It's 5 kilometers divided by 1 hour, so that's 5 kilometers per hour north. If you walk from your house to your friend's house 5 kilometers away and then return home in 1.5 hours, what is your speed? It's distance divided by time, so that's 10 kilometers divided by 1.5 hours. You get 6.7 kilometers per hour. What is your velocity? Displacement divided by time. Your displacement is 0, so your velocity is 0. Third example, if you travel to a store that is 15 kilometers north of your house and it takes 30 minutes, and then you return towards home but only go 10 kilometers before stopping for ice cream, and that takes 15 minutes. What is your speed? Distance over time, that was 25 kilometers divided by 45 minutes, and you get 0.56 kilometers per minute. What is your velocity? That's displacement divided by time. 5 kilometers north divided by 45 minutes equals 0.11 kilometers per minute north. Number 4, know the difference between speed and velocity and apply it to problems and conceptual descriptions. Example 1, if a car moves with constant velocity, does it also move with constant speed? Explain. Yes, because velocity is the speed in a constant direction. 2, if a car moves with a constant speed, does it also move with a constant velocity? Explain. No, because constant speed does not have to be in a straight line, whereas constant velocity does. Number 3, understand the concepts of displacement and distance to problems from the MOP app. So the example of Grandma Henderson challenging Michael Johnson in the 400-meter dash. Grandma H spins her wheelchair 5 times and gives up 15 meters from the starting line. MJ makes a complete circle around the track and stops at the starting line. So you want to figure out who has the greatest displacement, or are they the same? So Grandma has the greatest displacement because she is farthest away from the starting point. Displacement is comparing your initial point and your end point. Michael Johnson starts and ends at the same location, so his displacement is 0. Grandma has actually moved 15 meters away from the starting point. It says at the bottom, replace the word displacement with the word distance, and is the answer still the same? So why or why not? So now if we're going to compare their distances, Michael Johnson travels 400 meters. Grandma Henderson only travels 15. So Michael Johnson has the largest distance traveled. Number 2, understand the concepts of displacement and distance to problems from the MOP app. So we've got the football coach, and he's walking back and forth across the sideline. So if we're looking for his overall distance, we have to sum up all of the segments that he walked. So from A to B, he went from the 10 to the 40-yard line, so that's 30 yards total. From B to C, he went from the 40 to the 0, so that's 40 yards total. C to D, he went from the 0 to the 50-yard line, so that's a total of 50 yards. And from D to E, he went from the 50 to the 25, so that is 25 yards. So if you add all those up, he goes 145 yards. Now, if you change and you're trying to find displacement instead, we are only concerned about his starting and his ending point. So if he starts at A, which is at the 10-yard line, and he ends at E, which is at the 25-yard line, he has traveled 15 yards to get from A to E, and it happens to be to the east. So the displacement is not the same as the distance. In this case, the displacement is 15 yards east. Number 1, understand the concepts of average speed and average velocity to problems from the MOP app. So you've got the teacher doing the following motion in 10 seconds, walking 2 meters south, then 4 meters east, then 2 meters north, and then 4 meters west. So if we're looking for the average speed of the teacher, we care about distance divided by time. The distance covered is 2 plus 4 plus 2 plus 4, which is 12. So she's covered 12 meters in 10 seconds, so that would be 1.2 meters per second. At the bottom, it says replace the words average speed with the words average velocity. Is the answer still the same? So velocity is concerned with displacement over time. Displacement here is 0 because the teacher starts and ends in the same location, so velocity equals 0. And one more bonus question. 0, understand the concepts of average and speed and average velocity to problems from the MOP app. Back to the Grandma Henderson and Michael Johnson problem. So for average speed, we're caring about distance over time. So MJ has 400 meters divided by some time, and Grandma Henderson has 15 divided by that same amount of time. So MJ is actually going to have the greater speed. This time, if we're concerned about average velocity instead, as it says at the bottom, velocity is equal to displacement divided by time. MJ's displacement is 0, so his velocity is 0. Grandma Henderson displacement is 15 meters divided by some time, so Grandma Henderson will have a greater velocity because she actually has a numerical value, whereas MJ has 0 velocity. So that's it for Chapter 3, Part 1.